Hypothesis test is a statistical procedure that uses sample data to evaluate the credibility of a hypothesis about the population. For example, if you're doing an experiment and you have a sample of boys and a sample of girls, and you predict that boys are going to perform better than girls, that's your hypothesis. If you see a difference, you want to see how much of this difference is real. That means boys and girls are really different, and how much of it is due to your sampling error. So basically, in any hypothesis testing, you have to consider 5 elements, starting with the null hypothesis. The null hypothesis is a statement about the population that states there is no effect. And the reason we have to have a null hypothesis is because the credibility of your hypothesis, your research hypothesis, is measured by knowing the probability of no effect. The second thing that you need to consider is the sample statistic. The sample statistic is simply whatever statistic or data or number that you collect from your sample. Also, you need to understand the standard error. The standard error is a measure of the average or standard distance between sample statistics and the corresponding population parameter. So basically, to test the difference between experimental group and control group, you need to see the difference between the mean of the samples and divide it by the standard error to get a value like t, and see how big is this t. If the t is large, that means the experimental group and control group are so different that it's not possible that the difference is due to a sampling error. But if the t is small, then you may conclude that probably any difference between the experimental group and control group is just due to sampling error. The other thing that you need to consider in hypothesis testing is the alpha level. The alpha level is the maximum probability that the research results are obtained simply by chance. So when you say, for example, my alpha level is 0.05, means that the test demands that there is less than 5% probability that the results are caused only by chance. So if you check your difference, the t-value of the difference between the two groups, and you see the probability of getting such a huge t is less than 5%, it means that your treatment is actually effective. Now, after you do your test, in this case your t-test, how do you report the results? Okay, how do you report the results of a hypothesis test after you do your hypothesis testing? First of all, in the literature, significance level are reported as p-value. For example, you read a research paper and which shows the difference between two treatments and the p-value is less than 0.05. That simply means that there is less than 5% probability that the result is caused by chance. Now, whenever we do a hypothesis testing, there might be an error in our conclusion, or we may have an incorrect conclusion. And there are two types of errors that we may make. One is type 1 error, and the other one is type 2 error. Type 1 error happens when a researcher finds evidence for a significant result when in fact there is no effect. So for example, you have two medicines and you're comparing two groups using these two medicines. and your hypothesis testing shows that there is a significant level, but this result happened because of your sampling error, not because the medicines are really effective. That's type 1 error, which is a false report, and that's a serious mistake. But fortunately, the chances of getting or making type 1 error is not high. Like I said before, it's usually less than 5%. Type 2 error happens when sample data doesn't show evidence of a significant effect, while in fact there is a real effect. The chances of type 2 error is high, but the risk is not that high. What are some of the factors that may change the outcome of a hypothesis test? First is the sample size. The difference found with a large sample is more likely to be significant. So if you have a larger sample, it's more likely to see a significant difference. And the other one is the size of the variance. This is the opposite of the sample size. So if the variance of your sample is small, it's easier to find a significant difference between the two treatments. So if the participants in your experimental and control group are similar in terms of their performance, you have a better chance of seeing a significant difference when you apply your treatment. Now we go to the effect size. So the effect size is used after you do your hypothesis testing. So for example, you have two groups and you do a t-test, and the t-test shows a significant difference. Now somebody is going to ask you, okay, the difference is significant, but how big was the difference? In order to answer this question, you have to calculate the effect size. And there are two ways to calculate the effect size. One is the Cohen's d, which is equal to the sample mean difference divided by sample standard deviation. If this number is like less than 0.5, it's considered a small effect. If it's about 0.5, it's considered a medium effect, and if it's larger than 0.8, that's considered a large effect. Like I said, there are two ways to calculate the effect size. One is the Cohen's d, and the other one is calculate based on the percentage of variance, or R squared. And the way it's calculated, you square the value of t in t-test and divide it by degrees of freedom plus t squared, and you get, so the larger this value, the larger is the effectiveness of your treatment.